Okay, welcome to my presentation for the Water Resources System Planning and Management Model. My name is Joanne Correa, student number 629-33590. Okay, so the background of the project. So the project topic was the hydraulic flood modeling simulation using the Hec-Ras software. We'll then use the one-dimensional scenario based on the Pongola River. So using the Hec-Ras 1D modeling platform, we create a steady flow of 2,500 meters cubed per second under subcritical conditions. The model will have 25 cross-sections or stations spaced at 250 meter intervals, and then the bank and channel roughnesses are represented by the Manning coefficient of 0.02 and 0.015. From the methodology, we begin the simulation by setting up and creating a new project on the software, the Hec-Ras system. We want to start by creating the base mode. So we begin by editing the geometry. In the geometry tab, we create each cross-section for the 25 stations. This data is obtained from the calculated station and elevation units. We then produce the 25 stations at 250 meter intervals. After the finalization of the cross-section, we save the project and we create the steady flow parameters. For the upstream station, we keep the flow at 2,500 meters cubed per second, and for the downstream parameter, we have a depth of 0.01 meters. Once the final parameter is set, we can run the simulation. If there's no errors encountered, the system was successful. If there's errors, we'll need to go back and just double check what went wrong. The outputs you can get from the simulation is a detailed profile output, a cross-sectional detail and diagram, and then the 3D modeling of the system. Okay, the final cross-section after the simulation was created. This shows the water level for each station as well as all the parameters given. You can also get the details for Excel purposes, and then you can use comparative data. Okay, the detailed profile output. This shows that the steady flow is consistent for each station as per our parameters. It shows the water surface elevation at each station, the energy line, as well as the slope velocity at each cross section. Okay, the 3D viewer model, this shows the entire system in the 3D view. So you can clearly see the water level for the entire river system. Okay, for the second simulation, we had to change the Manning's roughness sensitivity. So I did this by taking the original parameter and increasing it by 40% and 70% respectively. We then get new main channel coefficients of 0.0255 and the outer bank coefficient of 0.028. We then use this new parameter to run a new simulation to compare with the original base model. After running the second simulation and obtaining the results, we can note the following. The water surface elevations generally increased along all river stations. For example, at River Station 1, the water surface elevation rose from 71.78 meters to 71.8 meters. And then at River Station 25, the water elevation increased from 102.49 meters to 102.52. Although the change is small, there is still a difference. The velocity in the main channel decreased slightly as a result of the higher resistance with the critical sections. So River Station 8, 9, 10, and 14 still displayed near critical or critical conditions. The fraud numbers stayed the same, as well as the flow area and top width remained the same. Okay, on the conclusion of the project, it was noted that the results of the base simulation show hydraulically consistent behavior with gradual increases in the water surface elevation downstream and stable subcritical flow across all the cross sections. In the sensitivity tests, increasing the Manning's value resulted in elevated water levels and reduced flow velocity slightly. While the changes were relatively moderate or small, they do confirm that even the slight increase in roughness significantly influences the hydraulic output, especially in wider or flatter sections of the channels. These findings demonstrate that variations in the Manning coefficients directly affect flood depth predictions. The modeling also reflects the importance of integrating topographic data and detailed cross-sections. Okay, thank you for listening to my presentation. Please leave a comment if there are any questions.